Welcome back. In this video I will give examples of some vehicle performance requirements for cars and discuss the difference between continuous and short time requirements. For hybrid electric and fully electric vehicles I will also introduce requirements on the regenerative braking, and finally I will present a few other requirements relevant for the powertrain. It is often sufficient to define only a few driving situations which put high requirements on the powertrain, rather than force requirements for each speed. In this example, I will present some such required driving situations. They are not intended to show all relevant driving scenarios. Notice that the requirement values differ significantly between different vehicles. Of course, the vehicle needs to be able to drive at a constant speed on a flat road at all speeds it's designed for. However, the top vehicle speed is the speed which requires the highest force and highest power. Therefore, driving at top speed is the worst case requirement for constant speed on a flat road. Top speed driving can go on for an hour or more, and this is what we call a continuous requirement. How about climbing steep gradients? Well, it's unlikely that normal road vehicles will climb a steep gradient for an hour, but climbing steep gradients for 10 minutes is definitely possible. Therefore, we categorize these gradient requirements as long time requirements. This car is required to climb a 10% gradient in up to 100 km per hour. By plotting the running resistance curve for 10% gradient, we can find the force required at 100 km per hour. Another gradient requirement is 20% at 50 km per hour. Not all driving situations involve continuous or long time operation. Of course, high acceleration always means short time requirements, since the purpose is to swiftly reach a desired higher speed and then reduce the acceleration to zero. The reason for differentiating between long time and short time requirements is that especially electric machines have a time limit for how long they can run at high torque levels. This vehicle is required to accelerate 4 meters per second square at a low speed. The vehicle model is used to calculate the required traction force for this. The vehicle shall be able to keep that acceleration up to 50 km per hour. At higher speed, a lower acceleration is required to keep the power requirement at a cost-effective level. In this case, 2.5 meters per second square at 100 km per hour and 1 meter per second square at 150. As you can see, so far we have only specified positive traction force requirements. For a conventional powertrain with a combustion engine, this is sufficient, as it is the brake system and not the powertrain which produce most of the negative force. However, for hybrid electric or electric vehicles, the electric machine can regenerate power and charge the battery whenever the traction force is negative. Regeneration is, like acceleration, only a temporary situation and therefore a short time requirement. If the vehicle is a mild hybrid, the power of the electric machine is often limited. The electric machine is typically sized only for the levels of negative force which occur frequently. In most cases, it is not worth sizing the electric machine for strong decelerating forces, which occurs for a few seconds only. This mild hybrid powertrain is only required to be able to regenerate up to a 1.5 meters per second square deceleration at 50 km per hour. At higher speeds, decelerations are typically lower, and regeneration up to a 1 meter per second square deceleration is required at 100 km per hour. Note that the brake system can generate stronger negative force than this, so it is only the ability to regenerate power which is limited, while the vehicle still can decelerate much more. A fully electric powertrain will typically be capable of the same negative force as it can produce positive force, so for fully electric powertrains, regeneration requirements are much higher than for mild hybrids. There are other factors than speed, acceleration, and road gradient which can influence the powertrain requirements. Of course, the maximum load of the vehicle will influence the performance when the vehicle is fully loaded. The vehicle requirements may be specified only for the vehicle with driver and no other load, or it is possible that there are some additional requirements for the performance at full load. The acceleration time 0 to 100 km per hour is often an important requirement, not because it's important in normal driving, but because it is often used as the main measure of performance in car reviews. This requirement influences how strong force is required at speeds below 100 km per hour, but it cannot be expressed as a single operating point. The driving range on a full tank or a fully charged battery is another important requirement which may influence what powertrain is used in a vehicle. It is not sufficient only that a powertrain can produce the required force. The time it takes from when the driver presses the accelerator pedal until the vehicle is accelerating also needs to be short enough. This response time can in extreme situations be in the order of 1 second for turbocharged combustion engines when the engine shaft speed is low, while electric motors have a much shorter response time. There are also requirements on noise and vibration, which can be important for the design of the powertrain. Beside these examples, there are many other requirements, but they will not be discussed in this course. In this video, we have given examples of requirements for a car and what force speed operating points that they require the powertrain to provide. Some important requirements are top speed on a flat road, driving on gradients, and acceleration requirements. For hybrid electric and electric powertrains, there can also be requirements on negative traction force during regenerative braking. Some requirements are for continuous operation, while others are only relevant for short times. Short time requirements can allow smaller electric machines to be used than if the required force had to be produced continuously. Now you can do some exercises to test your ability to find the powertrain requirements for some other vehicles.